Welcome everyone to Mark Voids a Warranty. I'm Mark, and today we're going. Now, you might be wondering, what has this done to offend me? And that's a great question. You see, they printed the model number too small. See how you can barely read it down there? It's like one of those things, but I can't see it anymore, and that makes me sad. So we're going to see what else is wrong with this thing. We're going to pop it open and see what's inside. I haven't really done any research on this yet, so I don't know the right way to go. I don't know if we can pry the screen off or if we've got to use the heat pad here, but I've got it ready just in case. So just begin with a quick look around and see if there's anything snapping out at me. Looks like an SD card slot is right there, so that's interesting. But I don't see any means of access. There's no... Let me get to an overhead view shot here. There's no separation in the case. That looks like one piece of continuous plastic. So then the question is, can I get underneath or behind that screen or not? And before I go for any tools there, I sure don't see any reason to think so. So that's looking like we might need heat. You know, I had an idea a few days back, and I don't know if it's a good one or not, but the general idea was if these things did have some case screws hiding under them, I might be able to discover those with a magnet. But then again, that could just be a piece of something else. So certainly something magnetic there, something magnetic there. Those could also be speakers. And maybe something there that's magnetic. But again, look, speakers. Those are speakers. So my clever toilet lever trick didn't work, but there's something highly magnetic right there. I just don't know what. Or ferromagnetic. I mean, the fact that it just flung it makes me think whatever is there is magnetic in itself. I bet you that's for a case. Okay, so that provided zero clues. But that would have worked for our Fire HD, not our Fire HD, but our Kindle Rev 1. Dang it, not Kindle Rev 1. What was it? Echo Rev 1. I tell you, I can't do two things at once. Okay. So we are certainly not prying underneath that screen. So let's turn on our hot plate and set it to hot. Okay. Is it heating up? I don't know. Now it's going. It just wanted me to press the set button. So, while I'm letting that do its thing, I did, just in case, I did bring along a second project while we let that heat up. And that is my board from Teach Me PCB. So Teach Me PCB is a web course that's sponsored by Royal Circuit Solutions, who also sponsors these videos, by the way. And we created macro pads. Unfortunately, I made a boo-boo on mine. And I forgive myself for this one because this was a bit of stupidity on the part of the manufacturer of the WS2812s. See these things right here? These LEDs? See that little notch right there in the corner? Let me get a point and stick. See those guys right there? That is not a pin 1 indicator. Like everything else in electronics, right? You indicate pin 1. Not these guys. That is a pin 3 indicator. Because why not? Why not make my life unnecessarily difficult? Why not? So all of these RGB LEDs gots to go. They have to come off. No two ways about it. So I could work with those with you maybe, and we can pop those things off while we're letting our Kindle fry here. That's interesting. Okay, so I was about to move the heater block out of the way, and I have it set for like 105 degrees, and the temperature says it's 120 right now, so it seems to have overshot by quite a bit. It's coming down now, but that is interesting. Let's see here. Doesn't feel too hot yet. So maybe it just needs to figure out life. We'll let that sit for a few minutes while we work on our other project. And just to give you a idea of what that is this board right here. And our job is to find a way to get these little WS2812s off of the board without damaging, hopefully, the WS2812s, and definitely not the board. That'd be bad if we hurt some other things. So I am going to pull out a soldering iron and see if I can do it with that, because I had a buddy tell me that hot air tends to irreparably damage these things, and I don't want to do that. So, soldering iron on. While I'm doing this, by the way, if you're out there in TV land and you have any questions, ideas, or suggestions, please feel free to shoot me a text through YouTube. I'd love to hear from you. And again, this is just a temporary thing while we wait for our Kindle HD to get too hot to touch. All right, we're switching to Microscope View. And those are the guys that we are going to try to get off. And maybe while we're at it, we'll go after a little bit of that cat hair. I don't know. So this is the LED. Everything here is, or was, hand assembled. And one of my favorite tools for desoldering is this stuff called Chip Quick, which mixes with the solder and drastically lowers the reflow temp. So while I'm letting the iron heat up, I would like to put a tiny bit of solder to retin my tip. It's looking a little unshiny. And you always want a soldering iron that is shiny and clean, so that it best conducts the heat. Okay, let's get in there and give it a shot. That should be long enough. We're not melting yet. And I'm just going to move this around a little bit so it's easier to get to with that iron. And then we'll see what we can do. Okay, so everything is a little bit of Chip Quick applied. So now we just have to see if we can get underneath this thing. Come on, you know you want to. Let's get something sharper. Nope. Well, I've got more than one tool in my arsenal. Okay, give that a second to settle. Chip Quick is very, very brittle, which is why we don't use it for other solder joints. Also, you can see some bodge wire there. I initially had this designed with some LEDs. Oh, not LEDs, but diodes. There we go. It's free. Now we'll have to go through and clean up those pads a little. Anyways, I had some diodes in there that ended up not coming in. So, oh well. Wonder if I have a brush handy. I do not. So I'm going to get the rest of that material out of the way with some solder wick. You guys can probably get a little bit of a better view if I readjust ever so slightly. These are the pads that I'm going to try to clean up a little. And I'm a little awkward on the gun because I have half my workbench set up with a very, very hot plate that I am giving a very wide berth. Come on, soak up. Not really seeing it. So, oh, I guess it is in there. I'm just not seeing it from my perspective. All right. Trim that off. Do another pass here. See if I can get any more in there. Like I said, that Chip Quick stuff is not good for soldering. So I want to make sure those pads are as clean as I can get them of that. And then I'll come through with some IPA later. And go from there. All right, I'm going to melt a little solder back there on the surface, and then I'll pull that off too, and hopefully that'll be mixed sufficiently that there won't be enough Chip Quick left to matter. In fact, I kind of think I might want another couple degrees on this iron. Everything's melting a little slow, which is good. That lets me know that there's not enough chip quick left there to be causing a ruckus. Come on. Well, it's certainly soaking into the braid. I'm just not seeing it. So I guess it's soaking away from me. Well, as long as it soaks up, who am I to care, right? All right, we're having a good old time here. For those of you that are just joining me, I've got an Amazon Fire HD that I wasn't able to pry open, so it's sitting on the hot plate, getting toasty warm. And while I was doing that, I am just doing a little bit of repair on a board for another project. All right, so I think those are ready for a little IPA. And no, that's not Irish Pale Ale. That is for isopropyl alcohol. All right, so you can see I've got a kind of a crowded workspace there. But here is our hot plate, and we're just gonna see what there is to see. I might have to run and grab a pair of hot gloves here if this ends up being too hot to touch. That is warm, but I can start to get underneath it. I'm not seeing any glue yet. I think we just got the plastic loose, made it a little more pliable. Looks like there is no glue. Okay. Well then, we'll turn that thing off. There we go. Okay. So, we've got it open. Now let's just safely move Mr. Hot Plate out of the way. And we've got a party. All right. Well, that was interesting, wasn't it? So this particular model, whose model number I can't read, which is why we decided to tear it apart, is a little toasty warm at the moment, but not too hot to touch. And we've got our first view of the innards. I'm just going to clean up my workbench ever so slightly. And it turns out that it was all just snapped together. There were no adhesives used. But I didn't know that because I don't go online and look this stuff up beforehand. A couple interesting things so far. It looks like they have some cavities built around the speakers. That's interesting. See, so these things are, I don't know, a couple millimeters deep. And then you've got your speakers built right there. Speakers are soldered straight to the product. Let's see how we get our battery off. Looks like we've got tape in, maybe some glue. Feels glued. Just what I need. A hot, damaged lithium-ion battery on my hands. Oh, this makes me uncomfortable. So the lithium-ion is certainly glued in. And I guarantee you now, it is damaged. Great. Don't worry, I keep fire blankets nearby. And I've got 2 cats in the room who I guarantee you, when they get frightened, they pee. We just have to make sure we direct their puddles of fright. So right now I'm just, oh jeez. I bent my little tool. All right. Oh boy. We're going to keep that where I can keep an eye on it. And on a platform, so if I have to go running outside to eliminate that thing, I can. So one interesting thing on the back side here is a piece of copper that offers some amount of shielding. And it makes me uncomfortable. All right. We've got the LCD with a tiny little flexible PCB. Instead of using an FFC, this looks custom, probably for length, with a little ZIF connector on either end. It's going to be glued in. So that's running their data and power to the LCD. And man, let me show you these connectors under the microscope. That is some high density stuff. Cool, huh? But look how misregistered those vias are. That's one of the reasons I always like doing teardrops on high density stuff, because if those holes are drilled in the other direction, in the direction of the trace, you know, you could easily break that trace and, you know, drop your yield. That's off by a lot. Wonder if that was purposeful. Then they've got copper ties every so often, so I'm guessing each one of those they did differential pairs with guard traces. Let's see. Nope, these are off in another direction. So those aren't purposeful. They just drifted. They wandered. But yeah, if they were off just a little bit more, see how easy it'd be to break those traces? Not for me, buddy. Not for me. That's why I use teardrops whenever I can, or keyholes, or you can even design custom pad shapes if you want. Nothing says that your annular ring has to be round around there. So back to our overhead view. And again, feel free to ask questions as we go along. So that's the connector for the LCD display. Now we've got to get that board out, and it looks like I just have a few tiny screws in there. Probably you guys want a closer look. You can see them a little easier. See, there's 1, 2, 3, 4 at the top, so we'll start with that. I'd also like to remind you here, while I'm doing that, that Mark Voids a Warranty is on every Friday, and it will be for the foreseeable future. But we need more viewers. Now, I can't ask you to view on more than one device. That wouldn't make any sense, and it just provide, echoes and feedback and stuff. Instead, I want you to get your friends into it. Get them to subscribe. Get them to like. Then go get your neighbors. Then get your friends' neighbors. And then get your neighbors' friends. But we're trying to get subscriber count up into the 500 range. And we're really close. Just not close enough. Once I do hit 500, I'm going to be taking apart a broadcast video camera. All right, so there's a little piece of tape here. I was looking to see if there's a screw underneath, but it's just the connector for the camera module. So that is now free. This stuff is all so impossibly small. There's a Kapton over something. I'm just looking around to see if there's any screws I missed. I don't see any, but sometimes I can see more on the monitor than I can with my eyes these days. Okay, I don't see any. So will it come loose? It doesn't seem like it wants to. Well, how about my bent little spudger? Hi, Ollie Cat. Did you come in preparation of a battery fire? Okay, that is really stuck. I mean, I'm prying underneath, and I don't know if you can tell. You can't tell, but the plastic is coming up underneath it. So this thing must be glued down, just like the battery. So then that makes me wonder, what are the screws for? Oh, there's clips here. I missed those. You guys probably saw those. You're probably yelling at the screen right now. See, there's clips underneath. So then we need to get this thing, get the forward edge up. And then we might be able to pop it out. Okay, so while I'm futzing around with this, I would also like to let you know that my friend Joe Grand posted another video. So if you Google Joe Grand, he gets into a device that stores Bitcoin that somebody lost the password to, and he saves it for him. I guess he saved these people, a couple hundred, I'm sorry, not a couple hundred, but a couple $1 million that were a couple hundred Bitcoin. Okay, there we go. So there was some glue there, but it eventually gave up. Now all that's left holding this in place are a couple of wires that connect the speakers. So we've got our board free. Now I'm going to see if there's anything I can do. I don't think there is. There's little brass rivet inserts that we're holding that board in, and then little bits of foam, and then little bits of tape here. And was that it? Was that the only tape holding that board in? Yeah, I don't see any on the back side. So it looks like, does that foam correspond to those pads? Sure does look like it, doesn't it? Interesting. Wonder if that's conductive foam. Huh, I don't know. Interesting, interesting. All right. Now we can also clearly see how that this was held in place. There was some glue after all on the edges. So this is the front LCD, and this was a refurb unit. That's why we're taking it apart, actually. So I don't know if that's schmutz, but it sure does feel like glue. Yeah, there's glue at all the corners. Or there's schmutz at all the corners. I couldn't begin to tell you. And it looks like if I wanted to get that screen free, this thing would have to spend more time on the hot plate. I don't think there's I don't know, maybe is there a way under it? I don't feel anything glue-like. So maybe it's just glued at the corners? This is getting sketchy. Let's cheat. Yeah, I'm prying that thing full clear. So it must just be glued in at the edges. So I don't know if there's a way, if you're out there and watching right now. Josh! Hi, Josh. I think I missed your text. I was just looking to see how easy, if at all, it would be to get this screen free. So the black plastic clips that you're seeing were to hold the back case in. So I wasn't sure if it was glued or not at the time. Now I know that it wasn't, but heating up the plastic sure did make it easy to get out. Now what I was looking for now is there a way to get, for somebody that wanted to replace the screen, I was just looking to see how you would get that screen free. Because it isn't glued in the field at all. The field, so the whole area between the black plastic case and whatnot feels completely free. I was just curious. Obviously, you wouldn't want to do this on a device that you're trying to save. I just wanted to know how the edges were attached for the next guy, in case somebody did want to do a screen replacement or a screen salvage and put it into another project. So we're going to get a little aggressive here, and then we're going to go examine our board. All right. So Josh, how's your Friday going, man? I tell you, if you lived closer, I would have given you a couple bucks or a case of beer to put that computer together for me. I've got the parts behind me here. You might even be able to see a couple cases. Man, it's been a pain. Pain. I haven't built a computer in quite some time, and apparently the deal now is to make all the cables just barely reach, and you hide them and all that, and not fun. Okay, you know something? We might come back to this, but I think what I've learned is it is indeed glued in at the edges. So you would have to hot plate it to get that digitizer free without cracking it. Yeah, so you'd have to hot plate it. It looks like you're going for the glue around the parts that are black. So anyways, now we know. I'm not saving that screen, but now we know. All right, so let's go back to board and see what it is that we can see. Some interesting things here, a couple of via fields through vias. I don't know if they're doing those for thermal or what exactly there. A ton of vias over here. We'll see if we can't figure out what all these are. You can see test pads all on the back, which is great. You really want them only to be on one side. It makes setting up your test and programming fixture that much easier. Interesting unpopulated header there. I wonder what that's for. And then we've got a second camera. How about that? Oh, little baby microphone. Audio, micro USB, bunch of RF shielding. So what's this? There's a tiny FFC connector to this module, which could very well just be an RF module. I don't know yet. There's Kapton tape, a little tracking code on it. There is a thing under there, but we're going to have to go to the microscope. Oh, okay, so back to the computer while I'm looking this thing up. No, so I bought a new case. The general idea was to just build a brand new computer. I'm not on screen, am I? Well, let me look this up, then I'll tell you the story. Looks like we've got a name here. Goodix GT9110. I mean, I'd be willing to bet that this thing is a RF module of some sort, but I didn't see an antenna with it. But maybe it's just an all-in-one. I don't know. Anyways, it was the general idea was to build a computer, a brand new computer. So I bought a case, power supply, everything. Started putting it all together. Put the power supply in, installed the motherboard, hooked up everything, and then I put on the heatsink. It was huge. Could not close the case. So then everything had to come out of that case. And I took everything out of the other computer because that case is a little bit bigger and it's big enough to hold the motherboard and heatsink. So I just now, I mean, this was like 8 o'clock last night, so I didn't finish last night. But I just now got the computer in the old case, so the new computer in the old case, and got that closed up, so it's ready for a operating system. The other computer, the old computer, needs to go into the new case. That's not done yet. So right now, I am depriving you of warranty voiding. I am removing all of these RF shields off of the motherboard. They're soldered in place. I didn't want to use an iron. Okay, so here is our board minus those pesky RF shields that they put on to keep everything clear. Why am I not changing? There we go. So power came in here. One processor and shielding. Another processor and shielding. A bunch with a via fence. So we'll have to see what that was about on close-up here in a minute. And these must be the main processors and memory. And then backside, not much. Just the camera module and kind of an interesting way to attach it I haven't seen before. So they put it on sideways. Usually it comes straight off. So I'm still interested in what that unpopulated header is, and then we'll see what that header is too. So anyhow, let's move over to Microscope View. Yes, the air cooler heat sinks are out of control, but even knowing that, I wouldn't know how to spec a case for that. Elliot tells us the Goodix thing is a capacitive touch controller. Oh, well, there we go. That makes a lot of sense, Elliot. Thank you for sharing that with us. So then we still have to find our antennas and whatnot. So Elliot with the win. Funny thing, I've got people in chat right now. More people in chat than YouTube tells me are watching the channel. The last couple times, it's the metrics haven't been coming up correctly. On our last Mark Voids a Warranty, it told me that 0 people watched it, and I lost 2 subscribers. It was the weirdest thing. So, all right. So we are over towards the speaker side of things, and we have a lot of vias. A lot of via fences around the edge there. I mean, absolute ton of vias. Some absolutely impossibly small parts that have to be 010-005s. I mean, they're ridiculous. These guys, I'm thinking, are 0402s. The size is just incredible. So I think these are the 0402s, and then these are the 010-005s. I mean, I can't even see them. My eyesight isn't that great, so I'm not a great example, but I mean, just look at that. This is labeled U1908. U's are usually reserved for microcontrollers, so I wonder what microcontroller that is. I couldn't begin to tell you. S1. I don't know, but I mean, with all of these vias all over this area, that's usually reserved for RF energy when you have that much going around. It's possible. I don't know if Elliot wants to do a search for MediaTek MT-SS25LN 1720-AJCAL. Let us know what that thing is. See, there's a missing crystal there for something. Maybe they decided that they could run on an internal oscillator instead of an external crystal. I don't know. It depends on what MediaTek makes with that little IC. All right, so we move over, and you can see that things were laid out, you know, with a moderate amount of organization. Got another IC here. Topside markings are 105-VF H3J26G G313. I don't know what that is. Looks like it's got a small TSOP style package. And there's quite a few capacitors and resistors all around it. So you've got a couple different size, what appear to be capacitors. Hi, Ollie. A couple of resistors coming in. I really don't know if we're looking at signal lines. I kind of want to say we are, but I have no idea. Whatever it does, it disappears. And then a spot where we've got a copper exclusion. So maybe we're looking at, no, that doesn't seem right. That can't be an antenna. I don't know what we're looking at. Over near that other exclusion, we've got another IC, little quad flat pack package. All sorts of interesting things, including some missing parts that they decided they didn't need for whatever reason. Missing diodes, missing things that look like they might be for power regulation. So it could be that this is their response to chip shortages. They've got multiple circuits designed in here, and they just left stuff out that they ended up not using or not sourcing and went for a different thing. All right, we've also got a cat joining us. You're very quickly going to see Fat Ollie scroll across the screen. Hi, buddy. All right, another MediaTek ARM. So this is one of the main processors here, which then makes me think that this LPDA is a memory. FM432A1PH-GD-F, which then gives us another one, which is the Sky Hynix. I might as well rotate that around, make it easier on me. H26M64208 EMA, eNAND, memory. And those are all BGAs. So if you look around, no, Ollie, buddy, we can't be on the computer. No, I know it's fun to be on the computer, but you can't be on the computer. I'm sorry, my friend. We'll lift the desk in a minute, okay? And then you can look out the window and watch the wind blow. All right, so a couple interesting things about these BGAs. If you look at them, I mean, almost everything drops down to another layer immediately. You don't get to see any traces coming out of these. So they're really worried about EMI. So all the connections are made on internal layers. We don't get to see any of that. A bunch of decoupling caps that are kept close. I mean, not ridiculously close, but very, very close. So, interesting, interesting. Or as they say, clever, clever toilet lever. And we've got another IC over here, along with some copper exclusions. The only topside markings are 40X-U, and then is that a backwards 5? I can't really make that out. Is that a UZ? So interesting, though, the way that they excluded the copper around there. One of the connectors off here, you can see where they had thick traces that they necked down. Really seems like that they've got decoupling capacitors that could have been a little closer. And I don't know what those are. But it's interesting, as you move over to one part of the board, you see a particular set of layout rules and practices. Another one, you know, pretty orderly organization of support ICs and, support resistors and capacitors around the parent ICs laid out in another style. Oh, you can, is that a tiny pair of differential pairs? Yeah. God, those things are small. No, those aren't differential. They're just two traces coming out really close together. But anyways, it's another style. And then when we get to the right side of the board, another style. So, you know, it kind of makes me wonder if they took building blocks and put them together, or if you had different engineers working on the different blocks, and then they brought everything together. Interesting, interesting. All right. So that's our board. If there's anything else you guys want to look at, I'd be happy to look at it with you. Looks like mostly everything that we see is through-hole vias. But I'm betting with those BGAs, nope, we're not just seeing that. We are seeing HDI technology. I just saw right here. So those are just going down a layer. So interesting, interesting. I mean, copper pour everywhere. It's just weird that you see, you know, ridiculous levels of stitching over here and none over here. I don't know. Don't know. And then on our back side, again, ridiculous levels of stitching. None whatsoever. And then you start seeing little bits here and there, and then a decent amount. So interesting, interesting. All right, let's see if we can learn anything about that camera, if I can even find it. Those things are so small. I don't know if we're going to be able to get into this. So you can see some copper pores. They look different in flexible, because you end up doing hatched ground planes. So that's, you know, you're seeing aspects of that. And you do that for a variety of reasons. Flexibility is one. Some of the copper that you put on is made in different ways, different thicknesses. But the copper that you get on your PCBs is often rolled and annealed. They just keep putting it through rollers, heating it up, putting it through rollers until it gets down to a given side. But when you get to this type of copper, it's so thin they have to make it in a different way. So they have it electrodeposited on these rotating drums. Man, I don't know if I'm getting into this. I don't know. And then you can really get down to, you know, half ounce and quarter ounce copper. But those two different ways produce two different grain structures. And the rolled annealed is a little more tolerant of bending than the electrodeposited. I don't think I'm getting into this, folks. I can see if there's anything we can see from here. Whoop. I just took the lens off. You can make out the teeny tiny thing. So anyways, some copper is you can bend multiple times. Some copper you can only bend once or twice. But having those hatched ground planes gives you extra flexibility and still gives you a decent return path. So, all right, we're just going to have to settle for looking down through where the lens is supposed to go. So here you can see the tiny, tiny optical sensor that the image shines on. And you can make out some of the wafer cuts, kind of when I let the light hit it. All of this stuff is created in clean rooms by very talented people. And the scale is just absolutely amazing. Anyhow, you've got a ton of rows and columns that we can't even visualize with my optics setup. This is as zoomed in as I can get. And all of that information comes out of, you know, on these little traces. You know, there are a couple capacitors up there, decoupling caps, but everything comes out on signal lines and gets fed to a processor somewhere that figures out what it all does. I mean, that stuff is tiny. You can see, I mean, what appears to be, so if you look at the horizontal line on the screen, I can't really make out, but it almost looks like via fencing. It's not, I'm sure. It's connections. But it's fascinating stuff. Fascinating, fascinating. So, all right. So there's a camera, or the inside, as much of it as we can get out anyway. And that concludes what's left of our Fire HT device. I tell you, eventually, I'll learn how to get one of these things off without destroying it. But that glass is just so fragile. And I'm just, you know, hitting stuff with hammers. I go at this thing like Shrek or the Hulk would. But absolutely interesting. Very, very interesting stuff. So, with that, that has been another edition of Mark Voids a Warranty. And I would say that we've succeeded. And they're not taking that back. I mean, I guess I could try. I don't know. But I appreciate you guys spending your Friday lunchtime with me. It's certainly fun for me. Please remember to like, subscribe if you haven't done so already. If you have, please don't do it. Don't push it again, or it actually unsubscribes you. So that's no good. And get your friends to sign up. Get your parents to sign up. Get your friends' parents and your parents' friends, your neighbors' friends, your friends' neighbors, your friends' neighbors' parents. Get everybody. Because as soon as we get to 500, we're taking apart a broadcast TV lens. Thing's ginormous. It has to weigh 40 pounds. I'm excited, but I can't do it till we get to 500. All right. Well, this time next week, I should have a working computer, or Josh will have a case of beer. one way or the other, we're getting that computer up. But it's been a pleasure, everyone. Thank you to our sponsors, Royal Circuit Solutions, and everybody who